Hey guys, this is an application problem related to quadratic functions. Last week we took a look at shooting a cannonball into the air and what that might look like. And when that cannonball would hit the ground, the x-intercept, the output would be 0. And in this week's example, I'm going to relate quadratic functions to a situation involving money, revenue, and a profit. So let's take a look at it. Feel free, you'll notice it's in lesson 7 of the unit 6 and 7 book. You're welcome to turn there if you want to, write this stuff in, or if you just want to watch the video, that's fine too. Okay, so let's take a look. A company that sells movies online is deciding how much to charge customers to download a new movie. Based on data from previous sales, the company predicts that if they charge X dollars for each download, then the number of downloads in thousands is going to be modeled by this expression, 18 subtract X. Okay, so we're going to complete this table. We'll talk a little bit about what revenue is, and then we're going to look to see if we can see the connection between quadratics in this situation. Okay, move this up just a little bit. So if we charge people $3 for a download, then according to our expert model, they came up with it up here, then 18 subtract 3 would be 15. So if we charge people $3 to download, we're going to get 15,000 downloads from people, because this is all in thousands. If we charge people $5, then we're only going to get 13,000 downloads. And it makes sense, right? As the price goes up, less people are going to download the item, right, or the movie. If we charge people $10, then we're only going to make $8. I'm sorry, we're only going to have 8,000 people download. If we charge people $12, we're only going to get 6,000. Charge people $15, we're only going to have 3,000 downloads. If we charge people $18 for a download, then 18 subtract 8, we're not going to have any. Okay, that obviously is going to be way too expensive according to our expert model. So really, what are we doing to get this output here? If this is X, then we're basically just subtracting that, right? And this is what our expert model was. So if I were just to cover up this column over here, you guys can see if this is my input and this is my output, this is represented by a linear function. Okay, and if you remember from last week, we connected slope. Quadratics, one piece of a quadratic is actually a linear piece. All right, so we could kind of see this. This would be, starting at 18, the y-intercept, and then this is a negative slope. So we would be trending down as we move along, as we raise the price on downloads. Okay, all right, so let's talk a little bit about what revenue is, what that means. Revenue is basically, I'm just going to call it R. Revenue is the price that we charge people multiplied by the number we sell, right? So, revenue is basically saying how much money you make, right? So let's take a look at that. If I were to charge people $3 per download, and I were to charge, and there were 15,000 downloads, then I would make $45,000, right? Because this is 45 in thousands. Okay. So 3 multiplied by 5. How about 5 and 13? If I multiply 5 by 13, I get 65. So I'd make $65,000. If I were to charge people $10 multiplied by 8, that would be $80,000 that I would make in revenue. 12 multiplied by 6 would be 72. 15 multiplied by 3 would be 45. 18 multiplied by 0, I wouldn't make any money. And so what am I doing to get each one of these outputs? I'm multiplying the price by the number of downloads, right? So if I go all the way down here, I'm multiplying the price, X, by the number of downloads. So this would be X multiplied by 18 minus X. Okay, so this would be, I guess you would say, the equation or the expression that would represent revenue. And I'm going to ask you guys, is that linear? This one was linear. Is that linear to get this output? And you can see if we were to apply the distributive property here, this is not linear, right? This would produce that x squared. All right, so the question down here is the relationship between the price and the revenue, going from this one all the way over to this one, is that quadratic? And we would say yes, this is a quadratic function. And the reason we know it's a quadratic function, if I were to complete that distributive property, this would be 18x minus x squared. This would be the expression that would represent that situation, and that is a quadratic expression. Okay. Another way to think about it is using a graph. So I'm going to kind of expand on this question number 2, looking at this graph here. So on the next page, you guys will see a graph. So if we were to plot these points, I'm going to have my table here. And I'm just realizing that you might not have copied down that table, so you might want to just have it here. So I'm just going to write price and revenue, right? We're doing revenue as a function of price, right? So we're just doing that first and that third column. So 3, 45, 5, 65, 10, 80, 12, 72, 15, 45, and 18. We wouldn't make any money. There'd be no revenue. All right, so if we were to plot these points, so revenue's going all the way up to 80. Oh, actually, they already have the y in it, so looks good. Okay, so if we were to plot these points, 3 would be about right here, about 45, 5, 65, 10, 80. I just realized that was a little bit too high. That would be kind of 75. 65 should be a little bit below. 12, 72, 15, 45, 18, 0. And you should kind of notice what shape does that take. It takes kind of that parabola shape. So, thinking about it, as a graphical situation, we can see that, as we start to charge people, as we start to increase the price, what happens to the revenue? Well, the number of downloads go down, so the revenue is going to go down. You're not going to make as much money. And right here, we can see this x-intercept. That would be if we charge people $18, we're not going to make any revenue because nobody's going to download. So the question would be okay, well, where is the maximum? Where is that maximum profit, right? Where do we see that maximum profit happening? Well, according to the points that we chose, we can see that somewhere in between, right around $10, right? Somewhere probably between $8 and $10 right in here. This is where we're going to make our maximum profit. Make our maximum revenue, right? So somewhere in between $8 and $10, if we were to charge people $8 and $10 for a download, that is going to be our maximum revenue. And you can see why this would definitely be something of interest to maybe a business, right? Or YouTube, if they're going to charge their subscribers, or Netflix, things like that. What should we charge people a month, right? If you charge people too little, you're basically running a charity, right? And you're giving away your item for a very cheap price, and everybody's going to be downloading, or what, if it's a video, but you're probably not going to make a big profit. If you can try to find somewhere in that middle part where you're charging the right amount, not too much, not too little, that is where you're going to maximize your revenue. Okay. All right. Well, thanks guys for watching. I appreciate it. Have a great day.